All right, so welcome to today's professional machine learning engineer certification learning journey. My name is Philip Obiorah. I'm the lead for GDG Cloud Port Harcourt. Um, I'm also a learning development coach at University of Buckingham. Um, yeah, so we started the journey together to prepare ourselves for the professional machine learning engineer certification. And if you're just joining us, we have the previous videos here, our YouTube channel, GDG Cloud Port Harcourt. That's all. Just look for us on YouTube. Subscribe so that after this section now, we're going to be dropping this video on the channel. So this is day one, day two, day three. All right. So we are starting lesson 2 today. And yeah, so just I wanted to know where this thing is. And then if you registered before, then you must have received an email from us. Must have received an email of the instruction of what you need to do. The part we are following, this is the course we are learning here. So if you go to the cloud skill boosts, and this is 17. Yeah, this is it. This is what we are learning here. So you could start on your own, start learning. But when we come to these jams, we are having a collective class. If you have any challenges with this lab, you can ask the question as we progress. But this is the main course here, so that you can learn at your own pace. But the study jams is just for us to put everything together and then answer a few questions people might have. All right. So today we're looking at storing data. The whole machine learning process, where data is stored, is very important. How data is transformed is also very important. And then we'll also be looking at feature store. Of course, in your machine learning pipeline, you would, so apart from looking at the data quality and the storage options, so when you're looking at storing data, also you're looking at the choices you have to store the data, and then the transformation pipelines that you could use. So we are not just talking about models here. We're also talking about the choices you have to store data, because at the very first thing you need to do is to prepare your data, and the choice of the data, where the storage of your data, and the choice you make where you keep that data has a lot of impact. Yes. So where the data lives on Google Cloud and why that choice matter is what we're looking at when we're looking at storing data. And then how we're going to be transforming this raw data um, to become a real model, to become model ready, is what we're talking about in the transformation. And which kind of transformation pipelines do we have to use, or is possible for us to use? All right. And then when we look at feature store, we're looking at production grade feature management here. Yeah, so sometimes you might have done the cleaning and everything, and then you've selected your features. You might want to reuse these features, but you want to keep track of these features. You want to use them again or reuse them. So feature management comes in here. So these are very three concepts we'll be looking at for lesson 2. Lesson 2, data on Google Cloud. All right. So why is this topic important? Why is storage important? Now let's go to storage. Why is storing data important? Um, if your location of where you store data, if it's very poor, it could lead to high latency or high costs. So you need to make right choices where you're storing data, right? So at the point of your ingesting the data, at the point of storing it, after ingesting the data, after bringing the data, bringing in your data, after data selection, where do you store your data? If it's far away, if it can cause latency issues, it can increase your costs, or it can also affect the training serving, your training and serving. It has a lot, of impact. Now, the accuracy of machine learning models does not only rely on machine learning models doesn't only rely on accuracy of machine learning predictions, right? But how your data quality and how correct your data is. Everything is dependent on data. So data is used to drive predictive insights, and make repetitive decisions. So if your data is not correct, if your data is incomplete, if your data is inconsistent, then you're going to have predictions that will be unreliable, regardless of model complexity. All right. So as we prepared for the professional machine learning engineer certification, you'll be seeing questions that have to do with data correctness and reliability. You're not just going to be saying algorithms or model questions, but questions that have to do with where do you store the data, the best choice to store the data, whether you're going to have latency issues when you store the data in certain locations. So be looking out for such things. And so now let's dive in. Now, the machine learning workflow, the first thing is it's just like you have these three stages of data preparation, modeling, and model serving. So this is not a linear process. You can see it's iterative. So you can actually do data preparation, do the model training, set them, and come back again, collect more data, or tweak the data, or transform the data again, train the model, serve the model, come back again. So it's an iterative process, and it's not a linear process. So just like when you're cooking a food in restaurants, you're preparing the meal, and then you have to model training has to be like experimenting different recipes or spices. If it's too salty, you might have to add more. If it's not salty, you have to add more pepper or something. All right. So model training, and then at the end of the day, you serve. Right. So well, we're going to dive deep into this right now in each of these different stages. Now, let's get started with the data preparation. Good. Now, for you to train your model, you might need large amount of data, right? And so you might need to upload your data. You need to ingest data from different sources. Now you might ingesting data from different sources like BigQuery. Which other places can you ingest data from? I need people's contribution. Yes, you can write it in the charts. Which places can we ingest data from? Um, why is the AI assistants the ones writing on the chat? Yes, you can unmute yourself and talk, please. Which other sources can we ingest data from? I want us to learn together, right? I don't want to be the only one talking. Um, all right, but anyway, let me continue. So we could actually ingest data from BigQuery, from the Google Cloud, or from streaming systems. All right, and after data ingestion, we after ingesting data, we might need to do feature engineering, transforming these raw inputs into meaningful signals. Do some feature engineering, convert some data type if we need to, remove um, some incorrect data on the rows, on the columns. All right, so might need to do some feature engineering, combine some features to get more columns. All right, and then sometimes the data types can be, our data type could be a streaming data or batch data. Streaming data could be games coming from sensors in real time, or maybe gaming applications. You have this real-time data coming in, and then we could also have batch data that you can actually do all together at once, and then analyze at once, and then produce the result of the analysis. But streaming data, you have to work on it in real time, analyze it, transform it in real time, and also use it for prediction in real time. So these are considerations that have to be made when you preparing your data. Is it your data source from streaming system, or is it a batch data? That will also tell you where do you store your data, if it's streaming data and if it's batch data. Is it a structured data or unstructured data? Is it tables? Is it in tables and text, or are they images, audio, or are they just tables? So if it's just tables, you have a structured data set, and then you have to be looking for structured databases or structured um, or storage options that are structured. And then for unstructured data, you'll be looking at storage options that support the unstructured data. All right. Now, the next stage is, we've talked about data preparation. Then the next stage is what? Model training. Now, this is also very iterative. So you train the model, evaluate the performance, and evaluate the performance, adjust the parameters of the data, train the model. So you keep doing this until you're satisfied with that. It's very important to know that training can be computationally expensive and strongly influenced by data volume and data quality. So you might have to spend more time training if then if you do your cleaning very well and then use the necessary feature, reduce the data set to what you exactly need, that can speed up your training time. All right. So then after injecting the data, training data, the next thing you might do is to serve the model when everything is ready. Now, what do we do in model 7? In model 7, we are looking at deploying this model. All right. Sometimes some people just build machine learning models and then they don't deploy it. And so how do we deploy this model? How is this model accessible? Is it accessible via an endpoint or batch job? All right, so this concept is what you'll be seeing in the questions we're going to be reviewing later on. Be seeing deployed, monitored, managed. Then you're looking at model 7. Um, so when you're looking at where is this model deployed, how is it accessible? Can it be accessed through an endpoint or a batch job? All right. And then when we're looking at how do we monitor this model, we are monitoring it for what? For what do we monitor? We are monitoring performance. We are also monitoring model drift. We're checking the latency, the time at which you send a request and the time the request comes back. All right. So these are what we are checking when we're doing serving the model. So for instance, you have your data preparation for, look at this analogy here. I said that preparing the raw ingredients, experimenting the recipes, model training, and then serving the model, serving the meal. All right. So customers experience serving, especially when you're serving the meal. Yeah, customers experience the serving, but all these things are done behind the scene, right? But then data quality depends on everything before it. But this is what customers are going to experience. This is the end user, what end users are going to experience. The served model. All right. So now, how do we know a good model? How do we get to train a good model? So there is this concept of finding the bottom. Finding the bottom here is um, machine learning is an optimization problem actually. So how do we get a good model? What we're doing is to find the to search for the lowest error. Okay, so at each point in time, we are looking for the lowest error. We are training the system to be able to find the lowest error. Now we need to know which direction are we going to move. We also need to decide how big each step should take. So we to do this, we have to do a calculate derivative, the derivative of each direction, because during model training, what happens is we adjust the weights, the parameter weights of the model, and then but to do that, we need to know which. So at each point, let's say the we are calculating the error. How far is this prediction from the actual value? And then if we say if we have a large step, training step, then it might jump to this point, and then we might find out that we might keep jumping around and it might not be able to get to this bottom, to this lowest point, which is the best point of the model. We might just be jumping around, adjusting the weights arbitrarily, and we might not converge here if we have big steps. But um, if we have smaller steps, so we're talking about which direction should we take. Yeah, so good learning rate determines the learning speed. Now, so at a point, to start from a point and then the learning rate takes over, it can jump to this point, overshoot. But then if we have a smaller step, we can go down a little bit, go down a little bit, go down a little bit, and then get to this optimal point here, right? So at any point during training, the model has a set of current weights. Now we keep asking, which direction should we move to reduce error? And then this is always answered by what? Calculating the derivative of the cost function with respect to each weight. So with respect to each weight, we calculate the derivative, and then the derivative tells us whether increasing or decreasing a weight will reduce loss. Okay, so this is what happens. And then these weights we keep adjusting, and that's what we call back propagation, because after it's when we have an output at this output layer, it calculates the cost function. It compares it with the actual result. How far away is it from y, which is the actual result? And then we calculate the derivative. It tells us how to which direction would this weight be adjusted. So it goes back again to adjust these weights. All right. So this is how the machine learns, keep adjusting the weights until it gets to this optimal point where you have the least cost. All right. So the cost is doing what? Is measuring how wrong the model is. How wrong the model is. That's what the cost does. And then we choose here, we're choosing the step. If we choose a large step, it will jump. It might jump from here to this point and we might not converge here. But if we choose a smaller step, it will keep moving and it might get to this optimal point. All right. So that is it. And so previously we've covered weights, the concept of weights and bias. Neurons, we've seen neurons, there are neurons, multiple layers of neurons. There are different layers, activation functions, Learning rates, yes. We've seen, we've also seen back propagation, and we've learned about the epochs, cost function, yeah, gradient descent, yes. So these are concepts we've learned. Um, so weights and bias is what the model learns, right? The model learns about the weights and biases. These are adjusted during the model training. Neurons and layers is the structure of the model. You can make it complex, you can make it simple. All right. And then activation function. There are different activation functions, the sigmoid function, rectified linear unit, there are different ones. But why do we have activation function? So that we'll not keep having linear functions to introduce non-linearity. That's why we have activation functions. All right. And then epochs is the pass, the full pass over the data set. Learning rate is the speed of learning, the speed at which it will be moving these weights. Yes, the speed at which it will be moving the weights. Um, Epoch is the full pass over the data set. You can have 3 epochs. It will pass through the entire data set 3 times. And then, yes, what else? Loss functions measures the error. And back propagation is how learning happens. It goes back, it retracts to adjust the weight. This is back propagation. It goes back to adjust the weight. That is how learning happens. And then the gradient descent is the optimization strategy to be able to get to this point. That's the optimization strategy, gradient descent. Um, so know all these concepts, and you'll be seeing that. Um, you might be seeing that in the exam. Okay, yeah, so this is weights and bias. We've talked about it, what the model learns, um, who to decide, the machine, when is it decided? During training, the model, the machine does what? Learns, adjusts the weights and bias. Okay, that's the weights and bias. We've explained that already. And yeah, so layers, neurons, activation function, learning rates. Now let's see. Good. So all this, it's also happens, these are hyperparameters. The number of neurons, the number of layers, the structure of the complexity of the model. These are hyperparameters. The activation function you want to use, you're going to set this, all right? And then you're also going to set the learning rates and the number of epoch. So you're going to set all these yourself. These are hyperparameters. All right, so and is how the model learns. This is what the model learns. The model learns the weights and bias. And this is how you're going to set how it's going to learn the structure of the model. Of course, this is set by what humans. You don't set this, you don't set the weights. The machine sets this automatically and adjusts it automatically, right? You set these hyperparameters before what? Training. Before you begin training, you set this. So you're going to be seeing questions like this. Whenever you see questions like this, talking about number of layers, neurons, activation functions, you just know it has to do with hyperparameters. And in fact, whenever you see any question that has to do with hyperparameter, know that that question has to be before training. But if you see a question about during training, how the model learns, then it might be tending towards weight and bias. Right? Yeah, someone has a question. Please go ahead. Can you unmute yourself? Hello? Does anyone has a question here? You can type it on the chat if you. I'm surprised it just. All right, go ahead. Yeah, can you proceed? I don't know what's happening, but just write it in the chat, raise your hand again, and I'll call you up again. Now, so there are different ways in which we can um, calculate error. So we have one of the ways is the root mean square error, which measures the average magnitude of prediction error. So what it does is the key characteristics of the root mean square error is that it penalizes large errors more than um, the mean average error. And then it's sensitive to outliers, very sensitive to outliers. It emphasizes interpretation. So lower, when you have a lower root mean square error, it means better model prediction. All right, so it's very useful for regression problems such as price prediction. Right, so yeah, we've seen the root mean square error, and yeah, so I think this is a concept we've already talked about, confusion matrix. When you are, of course, when you're looking at evaluating the model, at a point you have to look at the confusion matrix. Um, you have to look at it true positive and true positive, false negative. False negative is usually the type 2 error. Type 1 error is false positive. Now, true positive is the model predicts that this is true and is actually true. Yes, then false negative is that the model predicted negative but is actually false. Type 2 error. False positive. The model predicted that it's positive, that this is a cat, but it's actually a dog. It's false. Type 1 error. This is negative. This is not a dog, and the model says it's a cat. So a type 1 error. Whereas this is actually this is not a cat. Yes, and the model predicted that it is not a cat. True negative. Right? So and now this is what we use to get the precision recall. So how do we define recall? Recall here is of all actual positives. Of all actual positive, how many did we catch? How many did we predict correctly? Of all the positives, how many did we predict correctly? Now, precision here is of everything that is positive, how many we are correct? You can see the difference. So recall is about true positive all over true positive plus false negative. So you can see true positive is true. Everything here is positive, like true, right? Of all the positive cases, false negative is positive. So this is all over all positive cases. What fraction of um the positive that did we catch out of all the positives? That is recall. All right. And in this case, of all that is positive, how many we are correct? This is looking at correctness. of all, yeah, of all that we have predicted positive, all predicted positive, how many we are correct, actually correct? That's precision. So there are some circumstances where you might need to um, you might prefer precision to recall. So let's say, for instance, in um, in medical diagnosis, disease screening, we don't want to do screening and allow um, want to be able to catch every person, detect anybody that has breast cancer or a disease. All right. So, okay, let me say, for instance, during COVID, right? We want to catch everyone that has COVID. So even if you don't have COVID and we say you have COVID, we might treat you of COVID, but I mean, the risk is not much, right? Than when you actually have COVID and we allow you into the population. So you can see that the emphasis here is let's catch them all. Catch every positive case that is existing. Then you emphasize what? Recall. But when it comes to fraud detection, let's say you have this finance app and you want to be able to, what do we catch now? Want to detect fraud, right? You don't want to um, tell someone that is legit transaction is fraud. You only want to um, be precise. And if you say that this is fraud, let it be fraud. All right. Then in this case, we focus on what? Precision. So these are edge cases where you have to check if it's precision, trade between precision and recall. Yes, and decide which which to emphasize. All right, so we've seen this already. And then see, there's always a trade-off between recall and precision. So this is another example. Spam and not spam. So for the algorithm that detects spam, it could be slightly different from the algorithm that is not spam. Yes, I can see someone has a question again. Yes, please go ahead. Let me see if I can.
Okay, I just wanted to ask if instead of trading precision for recall, like why can't you have both?
Sorry, come again.
Okay, my question is just that you said you should either focus on recall or you do precision, or you focus on precision. But what I'm saying is that why can't you have both?
Yeah, I mean, you cannot have, why can't you have both? That's why there's a trade-off, because as you try to increase, we're still going to see that later on. As you try to increase as you increase precision, or rather as you increase recall, if you have a high recall rate, then your precision will be low. All right. When the precision, if we do this, if we have check now, so when our precision is high, usually our recall rate is what? Low. So just look for instance now we have um total fish in the lake is 100. We caught total fish, remember, total fish in the lake. For us to have a high percentage of recall, that means we have to catch all fish, right? We have to catch all fish. But in this case, we are catching 80% of the fish. And so there's a trade-off. There's usually a trade-off between precision and recall. So when you try to catch, just like when you widen the net, when you just want to catch, you don't want to catch rocks, you just want to catch only fish. So, but then when you widen the net, you're bound to catch both rocks because you want to catch all right? And but then when we want to make sure we only catch the fishes. So our precision here is we're using a smaller net. Our precision here is 100%. We are and making sure that at each time we do a prediction, we are catching just the fishes with no rocks. Precision is 100%. You can see our recall rate is what? 20%. So in this case, depending on the use case, we just decide on what to use. All right, depending on the use case. Good. And so this leads us to the area under the curve characteristics. Area under the curve. This provides an aggregate to measure performance across all possible. Now, good. So this, as we're increasing the threshold, just like as you're increasing the net, you would see that you will have different precision and recall values. So this graph would tell you, show you if you have multiple, many of these curves, you're going to see for each threshold how it's the graph it plots, right? So, okay. Yeah, so we've seen the example of fishing net, small net. Yes. Okay. So, any question at this point in time? Before we proceed, I wish we could just quickly, okay, we still have some more, okay? We still have some. Yeah, so we've seen that area under the curve measures how well a model ranks positive and negative. Yeah, so we've seen that. Then now this is very important. As you increase model complexity, you're bound to have underfitting or overfitting. But in between underfitting and overfitting is where everything works out well. The good fits. All right. So now underfitting is in underfitting, the model is usually too simple. You can see this is a linear, very straight line, very what simple. But then when it's simple, you have this is there's high bias. Is not able to understand the complex pattern of this curve, right? You're just using a simple straight line to try to fit this curve. So it's not simple. It's not using it. We can use a stretch rule here. All right. Then now when we move to the overfitting, here we try to understand. Okay, the model is everything is curved. We try to understand every part, every possible data point. That's what's going on here. So, but that's the problem. Yeah, the model is too complex. That's why it's able to understand every possible data point, right? But then the problem here is that it's like memorizing the data points instead of understanding the pattern. Is memorizing the data points, which is very wrong, which would not be good when you start training with new data. All right, so you want to strike a balance between underfitting and overfitting. All right. Yeah. So you're going to be seeing questions like this when there is high bias. What does it tell you? It tells that it's underfitting, right? And or when the model performs well on training data. If you're told that the model performs very well on training data, but fails to generalize to new data, then you should know that we are looking at overfitting here. But if the model is not even, it doesn't perform well on training data and test data, then there's underfitting. It's too simple. So you're making efforts to optimize to get the best fit. That's when you have your model. All right. So yes. Now, I mean, this concept is not new. We've explained this before for those that have been attending the classes. So during your machine learning, throughout your machine learning journey, once you get your data set, you're advised to have um, your data sets into three, have a three parts of your data. So you're going to have your training sets, validation sets. This is what you use for experimental. This is your experimental data sets. All right. So in fact, during in the certification exam, you might see questions that have to do with experimental. You just know that it's talking about training and validation. During experimentation, training and validation. Right? So you use the training data, training set so that the model will do or learn the parameters. Use the validation set to do what? To tune the hyperparameters. And then we use the test set for the final and unbiased evaluation. Now, the test set should and must be used only once. The test data must be independent and used only once. Very important, take note. Use the training set multiple times, model length, adjust the weight, learn different parameters. Do this for your hyperparameter tuning, the validation set. All right. So the training and validation set all together make up your experimental data set. So you have experimental and test set. Test set should be final. You see, evaluate the final model with independent test data. Very important. All right. So data sets, evaluate your final model with cross validation. So you have cross validation here. Training and validation are repeated across different folds. You can see different folds here. You have different folds. Each part of the training set are being split into group. So you can have multiple folds for training and then multiple folds for validation. Then the performance is what? Is averaged. All right. So instead of like preparing you for an exam and then I give you, okay, I want to test to know how far you've learned, and I give you one quiz. That is just training, just like once. But if I give you 5 quizzes and then use the average of the 5 quizzes as your performance, that's cross validation. All right, so the performance is what averaged across these folds. We train it, validate it with different folds, multiple folds. All right, so it's more reliable. Yes, but the disadvantage is that it's high computational cost, but it's more reliable. Like you're training across repeated folds, right? It's actually very good when you have limited data. You know, you don't have a large data set to work with. So it's very good. So we've talked about the bias variance trade-off and model complexity. All right. So you want to minimize loss and model complexity. You just want to find a balance between the model loss and the model complexity. You want to aim for a low training error, but balance, but at the same time, you don't want the model to be too what? Complex. That's the bias variance trade-off and model complexity. So this is the fact what is being factored in the model when calculating error. All right. So when you're doing hyperparameter tuning, you want to find a way of balancing all this. So this we've seen these concepts again. You see, it's repeating itself, but we're going to repeat it to emphasize this because yeah. So these are regularization techniques. Um, Usually, regularization techniques are actually done to reduce overfitting in machine learning. So there's early stopping, there's the L1 regularization, L2, the data augmentation, noise robustness. These are different techniques. And yeah, so just know it's for um, reducing overfitting, right? Yes, we've seen this before already. Now, Now, talking about storage, there are different options where we could store data. I think this just probably would have made reference to this when we are talking about storage. We could store data in the cloud storage, Google Cloud Storage, or there's Google Cloud Big Table, there's Cloud SQL, Cloud Spanner, and Firestore BigQuery. Right? These are different storage options. Now, each of these storage options depends we're still going to see the different storage options, when to choose each of these storage options. Depend on the data type. If is it objects, your data type and object, is it structured or unstructured? Not based on preference, not what you want, but based on the nature of your data. All right, so now let's start looking at we're still going to come back to these different options and to understand what each of them do. But before we do that, I'll say, okay, this will lead us to this point. So we're still going to reach there. So now, so if we have data type, if our data type is structured or unstructured, or there are two considerations to make based on data type or based on business need. So that's decision we have to make on choosing a storage option is based on data type and what business need. Now, the first decision is our data structured or unstructured. All right. So, for instance, we are using we are processing data from a streaming app, a gaming application, and a streaming data. So it's unstructured data, right? Then we now have to consider business need. Business need could be, do we want to use it for an analysis or do we want to use it for transaction? Do you want to use for analysis, instant analysis, or for transaction? All right, so there are analytical databases and transactional databases. All right, so now for data that is unstructured can be text, images, audio, files. What do you use? Use cloud storage. Cloud storage will be your best bet. You can see this is data engineering, but you see data engineering questions are also part of the machine learning professional machine learning engineer certification questions. So you can see this is a typical data engineering question, for those that have looked into data engineering before. So you could see that if your data, so you actually see a question that has to do with unstructured data, the company makes how documents, images, which options do you think will be the recommended storage? You could suggest cloud storage because this is unstructured data. Now, among the storage, cloud storage, you have different offerings. You have the standard storage, nearline storage, the code line storage, and archive storage. Standard storage is data, hot data we use every day. So if it's an application you're building and that application will make accessing that storage on daily basis, I mean, you have to create a standard storage. But if it's going to maybe doing verification once a month or accessing the storage once a month, then you can create a nearline storage. Of course, there's a cost implication. This will be cheaper than this, right? And this will be very cheap because you want to access data once a year. So when you put it's archived and nothing happens, so depending on the use case, you have to choose whether you want to create an archive storage, code line storage. Code line storage access the data every 90 days, and archive storage once a year, right? And now let's look at the whole picture of the different options. Now, good. So if we have if yes, we have our structured data. We're talking about structured data right now. Our data is structured. But now, if our business case is transactional, want to use it immediately in the application, let's say a banking app right now, is structured from different ATMs, it's transactional, want to decide immediately, want to use it for transaction to give them access to their money. This is instant, right? So we might have to put it on SQL, create a global scalability, make it global scalable. So we might have to use, if let's say we have a big banking system, and we're all over the globe, we're not just in one country, then we're going to be storing that data in Cloud Spanner. If we are just in one region or just one company in one state, we could just have our data in Cloud SQL. Very simple. But if we want a global scalable, very scalable, accept large data sets, then structured, global scalability, right? We use what? It's Cloud Spanner. So once you see global scalable, you know that the best option is Cloud Spanner, and it's structured. It's structured, not just that it's structured, it's transactional workload, and it's SQL, then Cloud Spanner. These are SQL data bases. All right, storage options. Structured. Now, if our data is structured, no, it's structured, but it's no SQL, then we can use Firestore. The best option is Firestore. If our data is structured, but it's an analytical workload, I mean, it's not used for immediate transaction. It's maybe we just want to have it in BigQuery so that later on the different data different data analysts can just create dashboards from it. Then we know it's an analytical workload. We store it in what? BigQuery. Now, if it's structured, analytical, but no SQL, the best option for you is Cloud Bigtable. All right, so just have this, take note of this, have this in your head somewhere. It's gonna come. You have questions that would mention structured, Analytical, no SQL. Just know that the answer is cloud big table. Right? Any question at this point before we proceed? So before, look at what I want. Look at what is left here. We have, stick around. We just have how many slides left? 41, 42. Look at what we're going to look at. Feature engineering. Then we're going to just dive into some sample questions. We'll just try and do some sample questions before we go. All right. So just stick around. And yeah, there's some sample questions here. Okay. So, all right. So this is it. Now, so any question at this point before we continue? Or we might just, should we call it a day at this point or continue next class, next Monday? Or should we proceed a little bit? Okay, maybe, please, maybe we'll stop here for today. And so that next week, Monday, look at what we are looking at. We'll be looking at the data set input formats, right? Different formats in which we can have our data set, different transformation, ways of transforming this data. We're looking at this transformation. Then we're going to look at these questions, answer these questions, and break it down, each concept, and then so while answering these questions, you would have an idea. So let's say, for instance, you're an absolute beginner, right? And this concept can be overwhelming. Just listen. Sometimes it's even better to know the questions before you start reading. It's an approach, is a way of some people read that way. They go through the questions before they go into the comprehension. All right. So even if you're an absolute beginner and we're talking about all this, um, and we start answering these questions, we're going to explain everything so that every absolute beginner will understand what's going on, right? And then why we are choosing the option, why we are choosing A over B, or why we are choosing B over C. All right. So please, if you've not joined the Google Cloud Innovators, do that to get your credits, and then continue with these learning paths. Continue with these learning paths and keep progressing. Yeah. So for those that like challenges, that like to be challenged, if you come to this link here, I think I'm gonna share this letter in the email. Please make sure you RSVP, you join the RSVP for this event so that you get emails, official emails. I'm gonna send this letter in the email, or I'm gonna put that in the WhatsApp group later on, or let me paste it on this chat right now. So for those that love games, not games, if you click on this right now, what's going on? Now this allows you to, while you're getting badges, right? I don't know why it's not opening well here, but sorry. While you're getting badges, there are these images. When it loads, what you see is you get points as you're getting these badges, and then you'll be able to redeem your points. There are swags, swags, t-shirts from Google. As you complete, as you get points, as you get a skill badge for each, so each skill badge you get is what? If you get 2 skill badge, you have 1 point. You just need 3 points. If you get 3 points, you get, there's something for you. You know, there's a point, something for you for each point. So if you want to be motivated by the badges and the points and the swags, then this is for you. I posted the link on the group chat. So I think let's call it a day today, so that we'll not keep the class so long. So that next week Monday, same time, same link. Meet everyone. Um, thank you very much. Let me have your feedback on how the class is in the chats, if you're happy with the class. All right. Thank you, everyone. There's any question before we wrap up finally? Any final questions? Remember, we're going to continue from here next week. Yes, we're going to be looking at different data sets, different file formats. We're going to be looking at different file formats, and we'll have a lot of questions. We'll not really have time to dive into deep into questions. So we'll have time to dive into questions, dive deep into these questions, answer them as if we are going to be writing the certification the next day, Yeah, we're going to be explaining each concept we don't understand here. Yeah, so get ready, get ready, get ready. Come prepared. So this is just lesson 2, right? We're all following this journey together, and when we are ready, we're going to write the certification. Okay? So if you're just starting out, this is a very good opportunity for you. I mean, so remember, the main course is here. I keep emphasizing so that we don't forget. This is the main course, right? So, but if you're coming to these lectures, when you start going through this, you'll now be like, okay, you can relate to the concept we've already explained. All right, it's very much easy for you to assimilate. All right, thank you very much. Thank you once again. Thank you for coming. Thank you for spending time to attend this study jams. Bye bye. Start the recording now. Stick around if you have any questions.